Hi everyone, welcome. Today we're looking at scientific notation. We have three learning targets with this one. This is from 7.3 in the book is what we've been looking at. First learning target is I can express numbers in scientific notation. Second target is I can rewrite scientific notation as a number. So we want to be able to go both directions with it. We want to turn a number into scientific notation form, and we also want to be able to turn scientific notation back into a number. And the third thing we're going to look at is we want to be able to add and subtract, and multiply and divide using scientific notation. And this will actually be covered later in class. I won't go into it on this video really at all, but it's something we'll be doing in class as well. Okay, so let's look at what we're dealing with scientific notation. What really is it? It's basically an easy way to take very large numbers or very small numbers and work with them. It's used often by scientists, researchers, engineers, mathematicians. Anybody in a medical field would often use this as well. It's used worldwide. It's a universal language that all researchers would be able to work with, so you would have data that could be easily transferred for one group of researchers to another across the entirety of the world. So that's kind of how it's used. And here's an example of what it looks like, and we'll explain how it works in a minute. But so 1.25 times 10 to the third is how this would be read. That is scientific notation. What scientific notation contains are these three parts. First, you're going to have a number between 1 and 10, and that's where the 1.25 comes in. You're going to be multiplying that, or times 10 to the third power. In this case, it's 10 to the third power. It will be times 10 to some power. We don't know what it'll be specifically until we see what numbers we're presented with, but it's always going to have a number between 1 and 10 on the front end, a multiplication sign, and then you're raising 10 to some power. So scientific notation will always have those components. So rules for scientific notation. And this is going from a standard form number into scientific notation. This is actually the scientific notation version of this number here on the left. So 35,230,000 can be written as 3.5230 times 10 to the 7th. You would not have to write this 0 here. It's optional. It would mean the same thing with or without it. Step 1, we would place a decimal point immediately to the right of the first non-zero number. So if we look at this number here, where we would place a decimal point would be right here. Second, we'd count the places we move to get back to the original decimal point. So here, to get to the original decimal point, we don't have one in this number, so that means it's at the right end of the number is where the original would be. And now we just count from our new place out to there. We got 1, 2, 3, 4, 5, 6, 7. Third step says if we move to the right, we got a positive exponent. If we move to the left, we got a negative exponent. We move to the right when we got from our new one to our original one. So our exponent is 10 to the 7th. So that's 3.523 times 10 to the 7th power. Let's look at another one. 45,309 in scientific notation, then we number between 1 and 10, just past our first non-zero number, would be 4.5309, and that would be now times 10. And now we count. From here we go 1, 2, 3, 4. It would be 4 places, and we move to the right, so it's a positive exponent. This other example. First go number between 1 and 10, which is just past the first non-zero number, so it would be 2.3 times 10 Let's count. So from our new one, it'll be 2.3. Getting back to our original, it'll be 1, 2, 3, 4. Moving to the left, so it's a negative exponent. 2.3 times 10 to the negative fourth. So now let's just look at going from scientific notation back to standard form. So here we have an example up here. We have 4.871 times 10 to the fourth power, and that turns into 48,710. In other words, these are two equivalent numbers. One is expressed in scientific notation, and one is expressed in standard form. So let's look at the steps we take to go from scientific notation into standard form. So if we look at where we are right now, we start at the current decimal point, which is right here. That's what step 1 says. If it's a positive exponent, we are going to move the decimal to the right that many places. If it's a negative exponent, we're going to move the decimal to the left. So we would start at 4.871, and we're going to move the decimal 4 places to the right because of what this exponent says right here. And we would end up then at 48,710. Again, if we look at it, and I'll just actually write this on here right now, if we started at 4.8 and we moved it 4 places to the right, 1, 2, 3, 4, the decimal point would end up right here. So we'd end up at 48,710. And basically we would just fill in zeros as necessary. In this case we had to add 1 0 to get to the end of our number. So that's going from scientific notation to standard form. And let's look at a couple more examples. And I'm going to just go through these now, actually. One at a time, and we'll see how we do it. So again, the 3 rows, we start at our current decimal point, so 4.8. We have a number of exponent of 4 here. So we're going to rewrite that then as we will move it to the right then 4 places. So from 4.8 we would go to the right 4. So that would be 1. And then we'd fill in zeros. 2, 3, 4. So from here we'd go 1, 2, 3, 4. So that would be 48,000. In this other case, we got a negative exponent. So we start at 2.7107, and now we're going to go 5 to the left. So we would need to fill in 4 extra zeros. So we would then have 0.000 27107. And again, we would have started here. Exponent says negative 5, so we got to go 5 places to the left. So we go 1, 2, 3, 4, 5, which gets us back to here. So that gives us a couple examples of going from scientific notation to standard form. Earlier we did examples from standard form to scientific notation. So if we follow those rules, it's really pretty easy, and we can take some pretty difficult looking numbers, very large or very small, and make them very manageable. Thanks very much for listening. Take care. Have a wonderful day, and we'll see you very soon.